Assalamualaikum, we are from group 16. We present about frequency and phase synchronization. The group member is Nur Syazwani binti Abdul Wahab, Syahira binti Ismail and Nur Hasina binti Muhammad Nur. In digital communication system, frequency and phase synchronization play crucial roles in ensuring accurate and reliable transmission of the information between sender and receiver. Frequency synchronization refers to the process aligning of the carrier frequency of the sender and receiver in the communication system. In digital communication, data is usually transmitted by modulating the carrier wave with information signal. The receiver needs to synchronize its local oscillator frequency with the incoming carrier frequency to accurately modulate the received signal. If the carrier frequency are not properly synchronized, it can result in frequency offset or causing the distortion and loss in the information during demodulation. Phase synchronization, on the other hand, deal with aligning phase of received signal with the local oscillator at the receiver. The phase of the signal represents the position of the waveform in the time domain. In digital communication, phase modulation techniques such as phase shift keying (PSK) are widely used to encode and decode the information. For accurate demodulation, the receiver must synchronize the local oscillator phase with the incoming signal. Failure to achieve the phase synchronization can lead error in decode the transmission information. Frequency and phase synchronization, also known as the receiver synchronization and carrier synchronization. Next is PLL or phase lock loop. This is the diagram in the phase lock loop. First is phase detector. Phase detector is a device that produces a measured difference in phase between incoming signal and local replica. Next is loop filter. Loop filter govern in the PLL response in this variance in error signal. As well, design loop should be able to track changes in the incoming signal phase but not overly responsive to receive noise. Next, we go to the MATLAB code. To write the coding in this assignment, we have to assume the parameters. So my group parameters is frequency sampling is 50,000, time is 1 second, frequency 1 and frequency 2 is 50. The phase offset is pi per 2, and this is the formula for generate two sinusoidal signal between frequency and phase offset. So this code is for frequency synchronization, which is estimate frequency 2, frequency 1 plus lag divided by frequency sampling. So this is the phase synchronization. The signal 2 corrected with this formula sin 2 pi frequency 1 t minus phase difference. So to see the graph, we use this code. For figure 1 is for original signal and figure 2 is the synchronized signal. The frequency signal is 50.01 Hz and the phase difference between signal 1 and synchronous signal 2 is 1.75 radians. So we will see the graph. This is the graph of original signal and synchronous signal. So the first graph is original signal and synchronous signal. They are slightly different at this is 1.75 radians. Conclusion from this, frequency and phase synchronization are essential elements of digital communication system. Frequency synchronization ensures the carrier frequency at the transmitter and receiver align with minimizing distortion and loss information demodulation. Phase synchronization align the phase of the received signal with the local oscillator at the receiver. Both frequency and phase synchronization are crucial for reliable and accurate data transmission. Phase and frequency synchronization play vital roles in ensuring accurate and reliable communication between sender and receiver in the communication system. They are fundamental to achieve optimal performance, minimizing error, and enable efficient data transmission and reception.